Hi, grade 10s. Today we are talking about the length of a line segment. So again, a line segment, as opposed to a line, just connects two specific points on the Cartesian plane. So we can actually find how many units long a line segment is using a different kind of version of Pythagorean theorem. Okay, so if you take any 2 points, so we're just going to call them A and B. So A and B, and connect them with a line segment. Okay, you can use this as the hypotenuse of the right angle triangle. So just like when we learn slope, we can create a right angle triangle beautifully. Okay, so this is our run, and this is our rise. And this actually creates a right angle triangle. So if you recall Pythagorean theorem, basically you have the hypotenuse squared equals this side squared plus this side squared. So we can rewrite it this way. We can say that the length of A to B, so writing that, you put AB with a line over it. This means the length of AB squared is equal to the run squared plus the rise squared. Okay, so the length of AB then is equal to the square root of the run squared plus the rise squared. So I'm just changing colors to show this specific example. If we take a look at this, we can see that this run is 1, 2, 3, 4, 5, and that the rise is 6. So the length of this specific AB is equal to the square root of the run, so 5 squared, plus the square root of the rise. Sorry, the square of the rise, so 6 squared. So this is the square root of 25 plus 36. So that is the square root of 61. Now, instead of turning that into a decimal, we're actually going to leave it just as square root 61 because this is an exact number that can be put into your calculator. All right, so we can take this further by actually using the coordinates of the endpoints instead of just using the rise and the run and actually having to count that. So if we label A with any given coordinate, x1, y1, that's just in general, that's a 1. And we label B as x2, y2. Remember that, change the color here. Remember that the run, there we go. The run is just equal to whatever this x value is minus whatever the first x value was. So x2 minus x1 just represents the run. And then the rise is the change in the y values. So the rise is just equal to y2 minus y1. So our distance formula, the distance from A to B, square root, squared, is equal to the run, so x2 minus x1, all squared, plus our rise squared, so y2 minus y1, all squared. So to get the length of AB by itself, we need to put a huge square root over this, and we have our equation. So this is the formula. So the distance between 2 points, which sometimes can be represented by little d, or sometimes can be represented by the 2 endpoints with a line over it, is just the square root of x2 minus x1 all squared So that's just how far apart the two x values are, plus y2 minus y1 all squared. So how far apart the y values are. It's really important to understand, okay, that this is just a use of the Pythagorean theorem. This is just the Pythagorean theorem using our definitions of what run is and what rise is. You may be asked on a test to explain how this distance formula was created. So in class, you will do another investigation to kind of come up with this on your own, but you are responsible for understanding why this equation is what it is and not just for memorizing it. So let's do a couple examples. Our first example involves actually plotting the points, drawing the line segment, and now we're going to find the distance. Okay, so our endpoints are called A and B, so we can note here AB with the line over it. This means the distance between A and B is equal to, and we start by drawing this huge square root. So we take our second x value and we subtract our first x value. So in that case, we're adding 3 since we're subtracting -3, and then we square it. Then we add our second y value, -4, and subtract our first y value, 5, and square it. Okay, so now we just follow BEDMAS. So the first thing we do is add within the bracket. So we get 5 all squared, and then -9 all squared. Notice that I'm still including these rounded parentheses, and you should think about why that's true. Because this -9, the negative is included in the squaring. So this -9 all squared becomes positive 81. -9 times -9 is positive 81. Without that, if you just had -9 squared, your calculator would give you -81 and you'd get the wrong answer. So now you get the square root of 25 plus 81. Make sure you extend that. And this gives you the square root of 106. And again, we'll leave it as an exact value. Okay. I would like you to try this one on your own. So please pause the video and see if you can get the square root of 40 for this one. And then I'll do it for you. Okay, so from C to D, you get the big square root of 5 plus 1 all squared plus 2 minus 0 squared. So you get the square root of 6 squared, which is 36, and 2 squared, which is 4. So you get square root 40. Now, in the back of the book, you might get something that looks like this instead. 2 root 10 and the square root of 40 are the same number. They're just written in different ways. Just like 3 over 6 and 1/2 are the same number, just written in different ways. So if you get answers in the back of the book that look like this, and you got this answer, don't assume that you're wrong necessarily. Take your calculator and turn this square root 40 into a decimal number. And then take the 2 root 10 and turn it into the decimal number. As long as these two decimals are the same, you know you got the right answer. Okay, example 2 is a word problem. So start by drawing an axis because we will be drawing a rough sketch. It's going to be pretty rough though. So an ambulance service uses a grid system to estimate flying times and fuel requirements. Coordinates on this grid are distance in kilometers east and north of a reference point in the lower left. So this is a reference point. So you could even think about, Essex County, and this could be Windsor. And so everything is like in terms of how far it is from Windsor, to the right and like to the east and north, or to the west and south, or whatever you want to do. In this case, it's not Windsor, but there's some kind of reference point there. So a helicopter ambulance picks up a patient at P96 197. So I'm going to estimate. Again, I said this was going to be pretty rough. So I'm going to say that this is P, and it's 96 197. And then at t, so 200, 296. So there is a hospital, and then there's a hospital in Sudbury at 232.80. So the question is, which hospital should this helicopter take the patient to? So the patient's here. Should they go to Timmins or should they go to Sudbury? Which distance is shorter? Okay, so yeah, your answer will depend on which distance is shorter, P to T or P to S. So I'm going to find PT in full detail, and then I'm going to ask you to pause the video and find PS. Okay, so from P to T, our distance is long square root. First, we take the distance between the X values. So 200 minus 96, all squared. Then we add, we're going to take the difference in the Y values. 296 minus 197, again, all squared. So when you do this, you get the square root of 104 squared and 99 squared. So you get 143.6 kilometers. Now you might be saying, Mrs. Wiens, you said you're supposed to just leave it as a root. You want it as an exact number. Well, within this scenario, saying that you're going to have the square root of 20,617 kilometers isn't useful to the helicopter technician, or pilot, I should say. They would want to know that it's, about 143, 144 kilometers from where they are to Timmins. So now you guys find out how far it is from the patient to Sudbury. So pause the video. You should have gotten that it was 179.4 kilometers. So based on this analysis, we can assume that Timmins is the better hospital. But what are we assuming? So you guys can write this out in more detail. Just with this trackpad, it's hard to write this. So listen up. So they should take it to Timmins, assuming shortest distance. Write out shortest distance is best. Okay, so what else would they want to look at? They would want to look at weather conditions, like is it snowing in Timmins but not in Sudbury? Is the wind unfavorable? They would want to look at, how busy the wait times are in each hospital. Maybe there's a huge wait line in Timmins and not in Sudbury, things like that. So you would want to write other different considerations because our result of Timmins, we're just looking at the distance, but there's other things to take into consideration. Okay, last question. This question requires you to take your knowledge you learned last video about what a median is, together with our new knowledge from today, which is finding the distance between 2 points. So it wants you to find the length of a median from P. So the first thing I did was draw the triangle. So take a moment to do that now and label your points. So if the median is from P, that means it goes to RQ. So we need to find the midpoint of RQ in order to properly draw this median. So again, you just take the average of the X values and the average of the Y values to get the coordinate 4, 2 as the midpoint. Okay, so now the median from P looks like this. So the question is, how long is that median? So now we just use our distance formula. So from P to the median of RQ, now notice that these are subscript, and I put a line over it to indicate that I'm finding the distance. So you just do long square root, difference between the X values. So 4 minus negative 2 is 4 plus 2 squared, plus 2 minus negative 2, so plus 2 squared. So you end up getting 6 squared, which is 36, and 4 squared, which is 16. So you get square root 52 units. Or I would say it's also good to include, in this case, about 7.2 units. Okay, now if this were like, housing and it was kilometers or inches or a lot of things, make sure you actually write the units. In this case, because no units were given, you just literally write the word units. Okay, so let's take a look at the success criteria. This is what you should be able to do as a result of this video. So discuss how the formula for length was developed. Find the length of a line segment if I give you a graph. Use the formula if I just give you the coordinates, and then solve other problems. So word problems, or the one like the question with the median I just gave you. Okay, guys, so there you go. That is the length of a line segment. Thanks for watching. Hope you learned lots.